which is a little more challenging than the previous types. Guys, I already have the type 4, example 4 here, which is 10x squared minus 16x equal to negative 6. So this is slightly different than the previous types. The first thing that you can see here, which is different from the last types, is like it's not set equal to 0. So our first goal should be to try to set it equal to 0, to have everything on the left hand side and 0 on the right hand side, which we know is not too difficult. We can actually bring that negative 6 to the other side and then we'll have a 0 on the right hand side. And guys, that is something that one has to do when one is working with these examples and one is trying to think about the factoring method or even the quadratic formula that we will learn and use later. One has to try to get it in the standard form. Because why standard form? Because it is already in the standard form up to here, and then we just have to bring it to this side and then have a 0, we'll get a 0 on the right hand side. So that would be in a nice standard form. Okay, so I'm going to add 6 to both sides. So when we do that, we get 10x squared minus 16x plus 6. We cannot combine any like terms on the left hand side. Here this crosses out. It is 0 on the right hand side. So that's in the standard form. Ax squared plus bx plus c equal to 0. Okay. Now let us think about methods for solving this quadratic function. Now again, to solve something like this, one may use a factoring method or one can use a quadratic formula. We don't know the quadratic formula right now, and as I said earlier in my previous video, it's very complex and complicated type of a formula. So if we can avoid it, let us avoid it. Guys, let us try to think about factoring method to solve this quadratic function. Now before we try to write the factors and all that, let us look at the coefficients carefully. There's a 10, there's a 16, there's a 6 here, and we can clearly see that they're all divisible by 2, right? So if they are divisible by 2, they're all divisible by 2, and we can simplify this, so we should go ahead and simplify. Okay, again, that is the key. If you can simplify something, you got to go ahead and try to simplify, because that makes life easier for you when you once you simplify then you start using the method on that, whether it's factoring or some other method. Okay, so I'll divide both sides by 2. And we can do that because dividing by 2 on the right hand side is not going to change the right hand side. 0 divided by 2 is we're still going to end up with a 0. So this becomes 5x squared minus 8x plus 3 equals to 0. So the given equation is slightly transformed, and now we are looking at this equation right here. Okay, it is still a little bit more complex than the previous one because the coefficient of x squared is 5. It's not 1 anymore. Guys, as I said in the previous video, the process of factoring does not really change much here. It is still the same idea of splitting the middle term. So what we do here is we take this coefficient 5 and we multiply with the c term, which is the constant term here at the end. So 5 times 3 is 15, right? And then we try to come up with 2 factors of 15, not any 2 factors, 2 special factors of 15 that add up to negative 8. Okay, and in this case, those would be, well, 3 and 5 works for 15, but we want a negative 8, so I can put negative here and negative here because negative times negative is still positive, so I'll still end up getting a positive 15 if I take the product, and if I add them, I'll get a negative 8, and that's what we want. We want to split the middle term, where the factors multiply to this term and they add up to the middle term. Okay, now there's some extra steps involved here. So guys, look at these steps carefully. As the word suggests, splitting the middle term, we're actually going to write that out. Okay, in my previous example, we could actually write that out as well, but we don't really have to write it out. So that's why I did not write them out, because just to save some time. Okay, but in this case, one has to just simply write it out and then see what one can do to get it in a simpler form. So it looks like this, 5x squared. I don't have to do nothing with 5x squared first. I only have to split this middle term, and this middle term can be broken down as minus 5x, and then there's a minus 3x, and at the end I have plus 3. Guys, if you put a 3 here and 5 here, that's totally fine. But I was able to see that there's already a 5 here, so that was the reason why I tried to combine the 5s together and 3s together. And as you practice more of these problems, you will see like why it's important. I mean, even here when I show you the next step, you will see why I actually combine them like this. Okay. Now I have these 4 terms right here, and I'm still trying to get 2 factors, right? To get those 2 factors, what one has to do is one has to use what is called the method of grouping. That is something you learn in the factoring polynomial section as well. So you group these 2 and we group these 2. Okay. When I look at these 2, I can see that the greatest common factor for these 2 is 5x. So I write this out. And once I take out that greatest common factor, then I have to see what is left. I'm left with x, because 5x times x is 5x squared. We have to make sure that when we distribute this, we should get the previous step. And then minus, what should I multiply here to get 5x? Just simply minus 1. 5x times x is 5x squared. 5x times negative 1 is negative 5x. Guys, same thing with this 2. The common factor, the greatest common factor is negative 3. Okay, it's only negative 3, no x, because this term does not have an x. And then what is left inside the parentheses? Inside the parentheses we have x, because negative 3 times x is negative 3x, and then minus 1, because negative times negative is positive, and 3 times 1 is positive 3. Okay. Now when do we know that we are on the right track? When these 2 look alike, that tells me that we are on the right track. Now if you look at this term and this term, we see that these 2 are the same. Since these 2 are the same, we can think of these as a common factor. Just take it outside, and then what is left? From the first term, I'm left with 5x, because it was 5x times this, and from the second term, I am left with minus 3. Don't forget there's a 0. Guys, please look at the step carefully. First, we multiply the coefficients, 5 and 3 here. 15, you come up with 2 factors that add up to the middle term, splitting the middle term. Then we actually split the middle term and we write the step. Minus 5x minus 3x here. Then we group first 2 and the other 2. From these 2, the greatest common factor is 5x. We take it out, and that is what we do when we simplify, or when we do the factoring. We try to take out the greatest common factor. You take out the greatest common factor, you're left with x minus 1 here. Similarly, you take out the greatest common factor in this case as well, which is negative 3, and then what are you left with? X minus 1 as well. As soon as you see that this and this look the same, the quantities inside the parentheses look the same, that already tells you that you're on the right track, and this can be factored. You take that out because it's the common factor now, and then what is left? From the first term it's 5x, from the second term it's minus 3, and here you have the product of 2 factors set equal to 0. Now you know if you have product of 2 factors equal to 0, then you have to set each one of them equal to 0 and solve for x. So from here, pretty simple. So this type 4 transforms into type 1, okay? And from here I have x minus 1 equal to 0, which gives me x equals to 1. And then I also have my other linear factor, which is this, and got to set that equal to 0 as well. And then you add 3 to both sides. 5x equals to 3. You divide both sides by 5, you get x equals to 3/5. So what is my solution? 1 and 3/5. Guys, you should check your solution. So checking your solution in this case means you substitute x back here and see if the left hand side equals to the right hand side for x equal to 1 as well as for x equal to 3/5. Okay, guys, this requires extra work, but it's based on knowing how to factor trinomials when the coefficient is different than 1. That is something one has to practice more examples on that, but once one is confident factoring those, then it's not too difficult to write the factors, and then once you have factors, you set them equal to 0 and you solve for the x. Okay, so guys, we covered 4 types, so please practice many examples on these 4 types, so that you become confident with these 4 types. Once you're confident with these 4, then we can build up and we can talk about other challenging types as well. Okay, so I'll see you in the next video with more challenging types.